Hi guys, today we're going to do proteins, which is this part here. If you look carefully, part D, all right, is quite a general topic, and a lot of questions asked on this. Just this part enough. So after this, I will one more lesson. I will cover this DNA, and this is very fast. And other things are left behind, and like resonance structures, so I'll finish off. And part E, you read up yourself, and I've got any questions you can ask me later. Okay? So if you look at it down here, right? Biodegradable, all these things, well, we have already done already. You know why they're biodegradable? Because of the linkage, the ester linkage and the amide linkage. Okay? Right. So of course, I will bit here and there. We will all these things here we will discuss under the general ideas of this part here. Okay. So today the focus is mainly on part D. But let me review what they want in the syllabus here. Distinguish, okay, between primary, secondary, alpha helix, and beta sheet, which is a secondary proteins, and tertiary structures of proteins. Explain the stabilization of secondary structure through hydrogen bonding between the carbonyl and the NH bonds of the peptide groups, and tertiary structures through interactions of R groups. Now you will see what all this means as we go through it. Okay, now let's go to the part down here. This is 199. Okay, that's the 199. All right. Now proteins. Okay. Remember, proteins are actually well, part of the three basic macromolecules every living thing has: proteins, fats, and carbohydrates. Proteins, the muscles are proteins. Your enzymes are proteins. The hormones are proteins. A lot of your body is made of proteins, and proteins is basically in your body is enzymes, you know. So it's catalysts. So proteins are very important. Okay, if you without proteins, that means your body cannot perform those reactions in a very fast rate, and you will probably die. I'll probably die without all these hormones and enzymes. So basically, proteins are made of, as we've done before, made of what? Made of amino acids. Remember here? Now we say here, see, they are formed from, right, amino acids, which is a carbon here. Now this is called R group. That's not we see in the syllabus here. The R group. This is very important. This causes a lot of interactions. Okay, cause interactions. Okay, between different R groups of different part of the amino acids. Okay, so that's why they have this thing called three-dimension lock and key and so forth. Now, of course, this is your okay, carboxylic acid here and your amine group here. Okay, as we said earlier, only one of your 20 amino acids is a secondary amine. This is a primary. You see here, this is a primary amine. Primary amine. So I've gone through this up with you already. Okay, of types of amino acids, non-polar, right? Very important. Now, non-polar means this part here, right? The R group here. This is the R group here. Very important. Which means the R group here is non-polar. Polar means like there's OH here. Okay, polar. That means it's not charged. Okay, it's not electrically charged. It means it's not negative or positive. It's just polar. Which means in this space here, right, is oxygen, because oxygen here, because I got alcohol group here, or sulfur group again. Okay, a delta negative here, delta positive here. So this is a partially charged, so it's called polar. Of course, if it is either a carboxyl group, now remember this is the R group. No, remember this is the R group. These groups here are all constant. They all have it. Okay, in every amino acid, the difference is this part here. This is the difference that makes it different. Okay, So if the carboxylic acid here, which means it will go to COO negative, so it's charged. If it's NH2, it goes to NH3 positive charge. So these are called charge, electrical charge. Okay, so this will interact with each other later, you will see. Right? So that's the revision of amino acids here. So, well, what is actually a protein? The protein here can be divided into, see here, proteins are made out of one or more unbranched polymer chains, which means that what is mean unbranched? It means, let's say now this is a protein, okay, a long chain. There's no like that coming out like that. Don't have, okay, right? Don't have. Only a long chain. So this long chain can be a straight chain, right? So this now, if it's a long chain, if there's only one chain here, now this is called primary protein. Okay, so they are made up of many amino acids, right, as monomer units. Okay, so each protein chain is a linear long chain, straight, built of its own selection of amino acid pool, right? And you know the mixed sequencing is determined by the DNA. Okay, we won't go into that. We used to have this in the exams, you know, in the syllabus. Okay, now what is the primary structure? All right. Okay, they will ask you one. Now there are three structures, three kind of protein structure here. The first thing, of course, when your body builds up, taking from, see the amino acids are called the ABCs. Okay, so the primary structure is like a long sentence. Okay. Right? Sorry, maybe words, like words are long sentence, okay? So they use all these ABCs to make a long word, okay? A super long word, actually. Okay, now this is a primary structure, right? I just go through first and I show you how the question come out, so you can actually see how you answer it. Now this is called primary structure. Sometimes people like primary structure, okay? Right? Can have a secondary structure, and a tertiary structure, and okay, one is called quaternary structure. Later you will see how they will come out. But normally they just ask you for primary, secondary, tertiary. Okay. Okay. Now what is a primary structure? So it's a linear sequence. The keyword is linear. That means a straight chain sequence of amino acids linked together by peptide bonds. So they are linked together by peptide bonds. Or basically, all these peptide bonds are because they form what? Only covalent bonds. That means the only kind of bonds here is covalent bond. Okay, for example, okay, I should show you the one example here. All right. Now remember, there is an end in this primary chain, primary protein here. There's a beginning and an end. Okay. Now it starts here. It starts with the end. Terminal. That means like here, it starts with here. Okay, and then of course C here and whatever R here and H here and here. Okay, then it goes on. Okay, now this is the first one. It will combine with another one, so it's NH here. Remember, means it join to the second amino acid here. Maybe okay, CH3 here and H here and here. Okay, and join to another one, N here. H here, and of course C, and then is a H here. Let's say here is CH3. Okay, and so I'm drawing now. Okay, I'm drawing a protein, a tripeptide. So this is called the N terminal. Okay, N terminal. That means it always start one. Of course, you find most proteins, right? They always start at methionine. Later I'll show you. Okay. And this is called the C end. It always end with a carbon in here. So it starts with the N and ends with the C. Okay? Right? All right. So now cysteine is the one that you find in your hair. It has got this disulfide bridges to stabilize the 3-dimension. Later we'll talk about it. Okay? So basically, this is called the this is a protein or it's a tripeptide. Okay, so primary structures or the polypeptide is determined by the genetic by the genes. All right. Now let's look at one here. Now, let's say for example, now this is basically a primary protein. Okay, so this is now glycine, this is your arginine, valine, glutamine, and so forth here. Okay, now all this here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 20. And there's 21 amino acids joined together. And every bond joined together here, right, is joined, and here we see here, by a peptide linkage. Okay, now, right? Every bond here like that is a peptide linkage. Okay? And basically all the bonds here is only covalent bonds. Very important. Okay, they will ask you what covalent bonds only. No other bonds. Okay, covalent bonds. Right? All these here are all covalent bonds. No hydrogen bonds, no van der Waals forces, no ionic bonds, only covalent bonds. The clear fact. Okay, now what are secondary proteins? So when the body makes all these, first thing they make, of course, is the primary protein. Then when the primary protein come together, because of the side chain, right, they get attraction to each other because of hydrogen bonds. Now see here. So remember the backbone is always backbone is the long chain here. I'll show you on top. Is it CCN, CCN? Okay. There are two C's followed by an N. Why? Because you see this is your nitrogen from here to here. Right. Now this is the amino acid here, okay, and this is your R group and this is your H, and of course this is your C, yeah. So it's NCN and NCCN, NCCN. Okay, so this is the backbone, right? Now this individual primary protein that can fold themselves. See, flexible. They can fold themselves. Because of hydrogen bonding, they fold themselves to form two types of secondary structure. Two types. As you say here, two types of secondary structure. It's alpha helix, which is like coil, beta pleated sheet. Okay, and they fold it because of the extra bonds now, hydrogen bonds, which are formed between the R groups. Form between the adjacent, because it forms between the many hydrogen, right? Between the adjacent peptide linkage. Now let's see. Okay, here we are. I got a few. Okay, now remember this is your primary image, you see now. Okay, right? Remember they always draw it out in the ionized state, NH3 plus, COO minus. They always ionize the whole structure here. So now the secondary one is this is called alpha helix. Like here, alpha helix. So they go round and round like a ribbon. Okay. Okay. Why? Because here, right? So you can draw now here the carbonyl group, okay, and here nitrogen group, and here here. This attraction is what? Is hydrogen bonds, isn't it? Okay, now let me draw now here. See now, this is the main skeletal. Okay, and see now. Right? Okay, now this H here is able to form hydrogen bond. Why? Because H to N is it? Any H to FON is it? Right? Is able to form hydrogen bonds in. Right now. So, but it must have a lone pair from somebody. So this one here, now here. So as it goes along here, now this is too far, right? So it's this fellow here. Okay? See now. So it's with the CO, lone pair here, and the NH a little bit further, but close enough. So it is delta negative, delta positive. And this attraction causes it to come together to form this coil. So now this is a hydrogen bond. So it's forming between this and the other fellow here, all of here. every one of these one here are hydrogen bonds. See? So they form this alpha helix because of the hydrogen bonds that is formed between the N, okay, the H and the N, and the other side for the carbonyl group. That's why in the syllabus say between this group and this group. Okay, hydrogen bonds form here. You must say that. So in this second structure here, there are two types of bonds. Okay, one of course is the long chain is covalent bonds, and the other one is what? Hydrogen bonds. Two types only. Okay. Now the other type is called the beta pleated pleat sheet. Okay, beta, isn't it? Okay, which means that means they will go like that. Go the primary protein go and then around here and go around. Okay, right. Okay. So now if you go like that, it's called what? Alpha helix. If you go like that, okay, in this parallel in this way, it's called beta pleated sheet. And also this one here, I'm going to rub it off here. There's too many things here. Okay, let's go back. Now, this further here, I say, let's put a dot one. Okay, see this carbon here, okay? As you go here and so forth here and coming back here, okay, right? And then this is carbon facing this way, and the nitrogen. So when they come close together, this delta positive, delta negative, and the lone pair here, what is from here? Hydrogen bonds. So here, all these form hydrogen bonds. So they get attracted to each other. So they stick quite close together, but so this is the one. This is the second type. So two types. So again here, these bonds here, these bonds here, these bonds here are all what? Covalent bonds. Because the main structure here is actually your primary amine, right? Your primary protein, right? Now, but between the carbonyl group and the NH group here are addition bonds here. What are they called? Hydrogen bonds. So there are two types of bonds. Hydrogen bonds, okay? For primary amine, only covalent bonds. Okay, now the third type is when they all come together. A tertiary structure. That means that here now this one is a primary, so they can like round here, right? This is a alpha helix, and then they can here, which is your beta position, round here. So inside here can form, but as they come close to each other, each of this one here and this one can interact now. They can interact, and they form the whole system here into a 3-dimension. Okay, it's called tertiary structure. Now you can see afterwards, you can see the kind of structure they expect you to draw. Okay, now I've got more diagrams here from the website. Okay, you can thank whoever does that. Okay, now I'll show you here. Now this is now, okay. Now one more kind of bonds is this thing called disulfide linkage or disulfide bridge. Now when you have cysteine or when there's a sulfur here, okay. Remember, right? Now this, of course, is your original okay, right? So there's CH2S here. Now, when they come here together, this hydrogen here can go off with the oxygen here. Okay, right? And the sulfur can bond, covalent bond, quite strong. They say this one is forming your curly hair, all those guys got curly hair because of this thing here. Okay, sulfur linkages, right? Because sulfur linkages or disulfide bridges. Okay, sulfur bridge. Okay, now this is another type. That means they can link two this and this together. Right? These two primary linear polymer can be linked together by some here. Okay, now this is found, as I said, in here. In your tertiary. Now this is a tertiary. You are expected to know how to draw this. You pattern, it's very simple. So now this whole thing here, right? You can see here, I'm going to use the, yeah. Okay. Now see, all these things here, the arrows here, all this whole strand here is actually your protein. The shape, they call it, it's called shaping, and the shape is same for a particular hormone or whatever. The shape is same. If shape is W, it will all be W. And why is shape W? Why is shape up and down here and here? Why? Why is like shape like this? No? Why is the shape go up here and go up here and down here? So for the, let's say this is the protein that makes your hair, and all be like that, right? Okay? Why? Because of this R groups here. See? Let's say for this fellow here, right? This is the R group. For this guy here, right? This is the R group. Okay? So when they come close together, these two here will form a kind of bonds. What kind of bonds can they form? Hydrogen bonds, See, because the C, H2, okay, O, H, and the carbonyl group of the carboxyl. Because there's a line here, okay. Okay, right? Don't pair here. Turn positive here. Okay, these bonds here, right? Okay, bonds here, hydrogen bond. See, so they stick it together, they hold it together. And of course, if here got a CH2 and an S and H here, and this one here, and the hydrogen come out and form what? Disulfide linkage. Okay, so that means they keep this together. The shape is the same for every similar protein form in the cell for a particular muscle, for eye, for ligament, whatever. Now, if the R group here is a alkyl group, like here, this is the R group, alkyl group, and it come near another R group here, alkyl group. Of course, this one is there's no charge there, so they are called instantaneous or dipole induced forces, van der Waals forces. They are weaker, right? Sulfur is stronger than hydrogen bonds. Okay, of course, this is weakest. Now, of course, it can also form your ionic bonds. So if this is, I'm going to put a different color so that is clearer. Now, this one here, this is the R group here. Okay, with the minus sign here. And the other R group, let's say the longer R group here, okay, with the NH3. So it's like this, the R group here, CH2, C double bond O, and of course here minus, it means that it has been ionized. This formerly this was a what? This was a carboxylic acid, the side chain, right? The R group, right? Okay, and this was a side chain amino, which means that this is the dicarboxylate amino acid. This is a diamine. Okay, so here we have, of course, CH2 and so forth. Of course, formerly it was like this. Okay, that is positive, right? Formerly it was like this. But in water, it will be ionized. So when they come together, this attraction is what? Is ionic bonds. And so they form this shape. They'll pull them together. So in a tertiary protein, how many, you need to draw this now. Okay, so practice drawing this diagram and draw all these connections here. Practice drawing the hydrogen bonds, the groups here, practice drawing the sulfur linkages, practice drawing the ionic bonds, and all these groups you must practice. And of course the R group and R group practice. Okay, so there are 4 different kind of bonds, right? 4 different kind of bonds for a tertiary protein. Okay, right? So these are they say that they are called interactions. I will show you the question and marking schema for proteins with tertiary structure. Okay, of course, as I said, right, like here, okay, here they talk about quaternary structure. So in your body there are 4 kinds, but they didn't say, they didn't put it in the syllabus. But you should know, for those who think biology, know. Now that means now this is a hemoglobin, no? A hemoglobin. This is a single hemoglobin. And the hemoglobin has got 4 of the same shape tertiary protein joined together. This is alpha, beta. 4 of them, they all stick together. And they must be 4. Every hemoglobin in your body, there are 4 of this tertiary protein here. Now this is a heme iron, this is iron. Fe. Heme means iron. It means one hemoglobin. Hemoglobin. Globin means what? Means protein. Can absorb 4 oxygen molecules. Here, 2, here, O2, here, O2, here, O2. Interesting, isn't it? God is great. It's fantastic how he could. How can, how can it evolve to form such a wonderful and all fixed shape, Why? Because of these, interactions between the R group, isn't it? All fixed shape. And why they're fixed shape? Because the protein formed in the hemoglobin is fixed. Fixed by who? By your DNA. Okay, your DNA makes all these proteins. And the sequencing of what alanine, ascorbic acid, or whatever is all fixed. If something goes wrong, then you become a mutant, X-Men, become an idiot. Okay, right. Now, while we have talked about all this already, I just show you the question before I talk about denaturing. Okay, we see how they are being asked, and so far, how are they going to, how you answer them? Okay, the first one is 207. Okay, let's say 207. I'm very conscious of the time. Okay, 207. All right. Now here, state and show using suitable diagrams. Okay, the types of bonding that occur in a primary, secondary, and tertiary structure of a protein. Now, primary. Okay, 3 of them. Primary, secondary, tertiary. Now, let's do 6 marks. No, look at this. I think it's 6 marks. Yeah, 6 marks. No. Okay, right. Now, this is I put according to this so I don't get caught. 08 here. How do you answer this? Okay, let's see here. All right, 6 marks. So protein, the marking scheme says that for primary, all right. Now the diagram, the diagram must show a peptide, okay, which means you draw like that, okay. Whatever is it, right? You can put an example. H, right, and N, and H, okay, and then C, and then let's do an example. You got the data booklet there, you can copy the name you don't know. This is what? This is your alanine. Okay, you learn something lah. Okay, I draw another one here. Okay, send here to what? To NH. They want to see the peptide linkage. See here, put the glycine here, okay, and so forth. Okay, put okay, and end up this one here. Okay, that's all they want. Okay, diagram showing that means you circle this. Okay, put what? Put where here? Where here? Peptide linkage. Sure, 1 mark already. Okay, you can put the whole thing, or you can put like this. Up to you. Right? So I say that all here are what? All these are what? Covalent bonds. So they are joined by what? Covalent bonds. So the interactions is covalent bond. Ignore amide-peptide. Okay, so the linkage is peptide. Okay, to the bonds. Secondary, right? You must say the interactions are hydrogen bonds. Okay, not between the side chains. No, not side chains. It's between the actual, this one here, isn't it? So you draw the 2. Of course, they didn't say 2 lah. You draw the what? The alpha, okay, the spiral, isn't it? Okay, and you put here C double bond O, put it, and okay, not the side chain, is the main thing here. Here delta, positive delta, negative, here. Okay, what? Hydrogen bonds. This is what you're going to do. Okay, and then you can draw your beta sheet. Okay, put C here, double bond O. Okay, not the OH, and here H here. Okay, okay. what? Delta negative, delta positive, and here what? Put your hydrogen bonds. Then put this alpha pleated, alpha helix, sorry. Is beta pleated. Pleated. P-L-E-A-T-E, okay, pleated. Okay. Good. Then tertiary. 2 marks only. No, I mean they should put more marks there. 2 of the following. You must show 2 only, but actually there are 4, isn't it? Hydrogen bonds. See, diagrams must show the hydrogen bonds with the side chain. No, okay, hydrogen bonds. Okay, okay, right? Other than those of the alpha helix and beta helix. Okay, that means they want a side chain. Ionic bonds or electrostatic attraction. Van der Waals forces between the R groups. Disulfide linkage of bridges. See, okay, suitable diagram of one of the above for disulfide S not this one here, not this one here. Must be S to S. Okay, not SH to SH. Not wrong. Salah don't want Salah. Very clear about this? That's why I say you have to look at here. Okay, look at here. All right. So I say you have to memorize this diagram here. Okay, right until you can get it. What's the page already? 199, 200. All right, you can see here. I told you this right. You need to practice it. Draw again and again and again until cow come home. And the cows, not cow. Cows come home. Okay. Now, draw this trick always come out. I show you there are 4 or 5 questions so far already. I wrote it. I'm sure there's more. So you must draw the primary, secondary, and tertiary. Okay, primary, secondary, the 2 alpha helix and beta sheet, pleated sheet. Okay. Now, of course, this one is very hard. This one is useless for exams, right? Just to let you know. But this is from from CRE one, the tertiary. See here, so here. See the disulfide, right? This one, make sure you know. Okay, make sure you can identify and draw all the bonds here. Hydrogen bond, disulfide linkages, van der Waals forces, ionic bond. 4 types of bonds. Okay, they call this interactions between the protein tertiary structure. You see now, I'm going to show you quickly that all these come up how many times. All right, just to prove to you, not to frighten you, but to prove to you. Okay, 210 quickly. Okay, I plan all this. Explain using diagrams where appropriate diagrams. Okay, the types of interactions between the bonding are responsible for the primary, secondary, tertiary. See all this? Yeah. Okay, they put the thing for you to draw and then put the blah blah blah. Okay, I can see here. The second one here, I put here as well. Say primary. Diagram shows. Okay, peptide linkage, covalent bond, hydrogen bonds between the NH and the Cl. See, tertiary, same marking scheme, not this good news. See, 6 marks. Okay, okay, okay. Do one more lah. I got all this thing. Okay, okay. Where is it really? See here? Oh no, I have a different one. Never mind. I got I think 4 or 5 questions like that. So now they are here. Okay. Here, of course. Okay, I show you now. This is hydrogen bonds or van der Waals forces. Okay, oval shape. Blah blah blah. This is what question? Okay. This will be 211. Okay, next one here. They say here. What is meant by tertiary or globular protein? Tertiary means what? Okay, tertiary means what? See here, one. Tertiary. Oh, is it correct? Never mind. Tertiary means what? Is the protein that will have interactions between what? What? Now see, primary no interactions between the R group. It is basically covalent bonds in the whole chain. Secondary, it is the interaction of the hydrogen bond between the NH2 and the C double bond O in the main chain, isn't it? Not with the R groups, no. Tertiary is the interaction between the R groups, isn't it? So tertiary proteins are formed when the R groups, okay, of the amino acids interact with each other through how many kinds of bonds? 4 kinds of bonds. Okay. I thought I put the thing here. No? Never mind. I want to see. Okay. I thought I did it. Okay, 02. They're here. But I don't know why. Okay. All right. You can see here. Okay, see here. Right. Six. Okay, you all. Question 1. This paper. Okay. 06 summer. 06 summer. 06 summer. 02 summer. Correct what? 02 summer. Okay. In the tertiary. Okay. 2 marks. 02 summer. First thing is they say it is a 3-dimension. Where's the pen? Okay, 3-dimension shape, right? Okay, all right. Contains structure that folds or coils. This of course contains alpha helix. Of course, it contains beta sheets. But here, most important, right? 3-dimension. I think they forgot something here. See, it contains on here, all right? That will have what? R groups. We have what? We have interactions. Okay. With what kind of bonds? 1, hydrogen bonds, which is actually here they talk about hydrogen bonds. 2, ionic bonds. 3, sulfur-sulfur linkages. 4, right? Dipole-dipole. 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 Instantaneous bonds. Yeah. Okay. Right? Okay. Of course, they ask you the other one is what is present one. Okay, it says see now here, R groups. There are 4 types of R group interactions which hold the tertiary together. 4 types of R groups. Okay. See here, right? These 2 of these are this one here. Of course, this one here is what? This one here is your the alkyl group, isn't it? So, right? Now this will form hydrophobic. It means don't like water, and of course, van der Waals. Okay. So that's how I form what? Something you just now. Okay. So what are the other one? The other 2? Ionic bonds and what? Ionic bonds and what? Hydrogen bonds. Right? It says here. See the markings here. P. See? Hydrogen bonds. Okay. Right? And ionic bonds. Okay. Between the polar groups, OH group. And you want to put OH group and what? OH group and your C here and C OH group. Okay. Right? And of course, ionic bonds between this one here and this one here. Understand? Okay? So these are the other four types. Remember? Four types. Right? Okay, let's go on. Okay? Now, let's see whether I got some more questions here for you. Okay, secondary. Okay, secondary. Okay, one more. 212. Next one here. 212. Then we go to denaturing, and we are almost done. Okay. Question 1. Name and describe the two secondary structures of proteins, giving simplified diagrams and showing the bonding in which the structures are stabilized. Easy, isn't it? So they ask for two. What are the two? Alpha helix and what? Beta pleated, isn't it? Pleated or bigger sheet. Okay? They ask you to draw simplified diagrams and showing the bonding, the interactions which make them stabilize. Now let's look at the marking scheme. Right? Before I go to denaturing, there is nothing there. Okay? What year is it? 04. 04 June. This is the next one here. I put in order already, so I don't know why. Okay, this is the one. Right? Okay? So this is the one here. See now. This is your what? Your alpha helix now. Okay? Show this here. You must draw this now. Right? They say no draw, but must draw. Here. Draw C double bond O and N here, H here. Okay, here put hydrogen bonds. Everything in exams, don't think they're not very chin chai, bonds. Alright, pleated sheet. Okay, so here, coming down here, here is your, okay, here's your H now. Okay, here's your hydrogen bonds. Okay. 1 mark for the pleated sheet, 1 mark for the stabilizing bonds. They draw here. See? That means this must be drawn for this here. Okay, now here. See? Carbon double bond here. Delta negative, lone pair, delta positive. Alright? So they ask in detail like this, you got to give lah. So here is ask only on secondary secondary type. See? Okay. See any more before we go on to denaturing and some other funny things. Okay. Last one. Okay. 220. They ask you for differences. Okay. I'm going to bring you all the types of questions so you can see the depth, the width, and height over here. Okay. Of how Cambridge will ask you, which means you need to know how to answer. Some of you fellows here are not very good English more. Okay, now here, of course here give K, J, and L. These are of course molecules found in your body, and of course it asks you which of these will be a building block for protein. Obviously must have a, okay, remember this is a secondary amine, isn't it? Right? It's 2 right? Must continue. Here don't have, but don't have the NH2, don't have amines, but don't have amines, right? So sugars. Okay, sugar. Okay, the one that don't need to go fat one. Okay, now here, we'll go on to here. Here, see now, this one they'll test you on the 3. Protein molecules have 4 levels of structure as the long molecules fold and take shape. 4. See, in a stable state about 3, isn't it? Right? What are the 4? Primary protein, secondary protein, tertiary protein, and what? In your quaternary 4. Quaternary protein. Okay, for example, you will find it in your hemoglobin. They all come together to form one big mass. Okay, that's what it actually does. Right? God's fantastic that you can't brains, you cannot challenge. Nothing very exists. Okay, the primary structure. Remember the primary. Sorry. Okay, yeah, the primary structure is a sequence Sequence means arrangement of amino acids in a protein chain. What type of bonding exists between the amino acids in this chain? The chain, of course, means what? Means a primary. Okay, right? For primary protein, what kind of bonds? What kind of bonding? Covalent. That's all. What type of bonding exists in all the other structures? Okay, okay. What type of bond? Okay, all the other types of structure. Of course, you have got what? Hydrogen bonding. Right? Hydrogen bonding. What else? Sulfur. Okay, sulfur or disulfide linkages. What else? Van der Waals. Okay, induced dipole. Dipole. What else? Ionic bonds, or we call it electrostatic bonds. Yeah. Okay. Name one type of bond that does not occur in primary or secondary. Easy lah. Okay. It can be what? Induced or what? Ionic bond. Okay. Can be induced dipole. Dipole, or it can be what? Ionic bonds. Okay, now that's the marking schema. So they ask you in detail on the type of interactions. Okay, remember they say what? In primary and secondary. Okay, right? Primary can have the sulfur linkage as well. Okay, especially in your hair. Okay, secondary. Okay, secondary can have hydrogen bonds in. Okay, now let's see what year this is. 11 November. I got it here. 11 November. Here, okay, 11 November. Here we are. All right. Last part here. Is it? Why is it all over the place? Why is it all over the place? Let's see here. This November 11, 43. 11, correct. Number 43. What question is it? Is it question 6? 11 November 43, correct. Part B. Okay. The first one is okay. Okay. What the bonds? No, hydrogen bonds and Van der Waals forces not. All right. Okay. See part 2 here. Part 2 here. Hydrogen bonds. Right. Okay. Sulfur you got. Okay. Van der Waals forces here. No, see. Right. One type does not occur in both primary and that one there. Okay. What is this? Okay. Why? Part C. Oh, this part B, sorry. I don't know what's wrong with this. Yeah, no, okay. Okay. Yeah, correct anyway. Right? Now, I finished all on this type of structures. Now let's quickly go to proteins are being denatured. Okay, what does it mean by denaturing of protein? Right? I'll ask you one. Wait, 200. Okay. Okay. Like for example, your egg. Famous of course the egg. Your egg, unboiled egg. The protein is the what is the the jelly. That's protein. Once you boil it further, now this is your this one here is like a tertiary structure of protein here. Once when you boil or you fry the egg, what happens is you break all these bonds in. This is 4 bonds here they're broken. See? Now I'm going to put put different color, green. Now all these bonds are ionic bonds. van der Waals forces, disulfide linkages, hydrogen bonds, all can be broken by many things. First, by heat. Okay, heat they call it denaturing. Denaturing. Okay, it means when you fry the white becomes visible there. Why? Because you break all these things, right? So the whole thing becomes, this becomes like that. So the different shape already. See now. Secondly, what can denature, break all these bonds? So heavy metals. That's why heavy metals can kill you. Okay, like silver. I know that some people, some races that they actually eat silver, which is supposed to be good, no. But of course, too much will kill you as silver because they will break out the linkages, right? Silver, copper, a small amount of copper is good. Okay, copper, mercury, all these things. Why are they poisonous for you? Because they break all these things. They can form bonds and break all these some of these bonds. Okay, 3, pH. Do you know that your blood is about, I think, how come I said I forgot, no? So there's a window. If you have too acidic, you will die, because it will break all these bonds here, right? And it will cause all these hormones not to work, and you will die. Okay, so these are the 3: heat, heavy metals, and pH. Now you can see down here. All right, I went through and cut down for you all these things. Denaturing. Okay. So pH and heavy metals. Heat, of course, is obvious now. So when you change the pH, so when the pH change, if the pH is low, it becomes acid. Your body will die of acidosis, acid, which is one at low pH. So what will happen? The amine group or amine group will, instead of this one here, will form hydrogen bonds, right? This now. Okay. So when it happens, this fellow here will go to the lone pair here, will form hydrogen bonds, the form is on. So this one here can no longer, the lone pair here can no longer form, say, breaks the hydrogen bonds between the groups. So the whole thing breaks, the shape changes, right? And see, all the catalyst works in body like a lock and key. So the key become different shape, different shape already, so cannot fit the lock. So your body cannot work. They cannot catalyze any reaction. That means you will die, See now, okay? So if it's a low, high pH, right? That means it's alkaline. Of course, now this fellow here, of course, also can form the hydrogen bonds, right? Okay? Or this fellow here, can form your with the OH. Remember not the see here. Okay, just to let you know what it is in. Okay, remember the hydrogen here. The alcohol propylene, CH2 here. Right? Again, see now. Here is hydrogen bonds in. So this one here, when sorry, better put the other one, otherwise it cannot work. For example, again. Yeah. Okay? Right? So when it's alkaline, this is gone. Negative charge here. So cannot form the hydrogen bond, so you break. So in these 2 places here, the pH actually breaks hydrogen bonds. So the whole thing becomes denatured. Okay, how about heavy metals now? I'll give you 2 here. This is a past question, okay? So silver can actually exchange with the hydrogen here to form a silver salt. So you need to put this equation, here H plus ion. Copper will break this. Okay, will break this and form 2 parts here, 1 part here, 1 part here, to form the sulfur minus sulfur minus. So it's 2 of them with 1 copper. Okay? So again, this sulfur linkage is broken, so the thing becomes denatured. Okay, so they ask you on these things, denaturing. Okay, now you can go back and read. Now, of course, here you can see the cooking of white eggs now. Okay, of eggs, the bonds are broken, so or bacteria will change milk to cheese. Okay, because the pH change, get yogurt, okay, same thing, right? So now there are different things. Now, one last thing before I finish off here. No time, 5 more minutes. Now, the other one, of course, is the idea of how do you fit in. If you hydrolyze, remember I told you before, for electrophoresis, you can hydrolyze your proteins on 666. Right? How do you hydrolyze protein? I always ask you, how do you hydrolyze a protein? Of course, in your body, you hydrolyze protein in acidic medium in your stomach. Pepsin, is it? Right? Okay. In the lab, you can also do it. You put HCl 6 molar, with boil for 6 hours. They will break, right? Normally, they will break into either a dipeptide or tripeptide, or just amino acids. Okay, now in here, I've got 2 questions here, which I think is quite good. It's using your brains. No, I'm sure you got brains. How to solve the kind of problems. 207, next patient. Okay, 2 questions. I want you to, I give you the first one and you try the second one. Okay, by yourself. Now here, see, very nice question. I mean, you use your brains a bit. If you have any, yes. If you don't know, then forget it. 2 marks. 2 marks only. Don't care. Some of you can do it. I know. It's too bad. Because you guys don't think. Analysis of a polypeptide, that means many amino acid junction, okay, show that amino and terminal, N is, see, I told you already, if you learn biology, the first amino acids in your protein is always a methionine. Right? You can see in the DNA is supposed to be that, okay, this is the starting point. The body will say, okay, let's make protein. The first one is, the code is for methionine. And then, right, and that the he said for this A, methionine is the start one, as METH, that means here, meth. Okay, not your drugs, and the carboxyl terminal is lysine. Okay, that means the last one will be a lysine. That means they tell you already, this is the starting, start, and this is your end. Very easy, I tell you already. So they got all these 3 letters. So work out the sequence of amino acid A using 3-letter abbreviations, each using once. Okay, so it's up here. Meth. Right here. I see. Okay, so we meth, ala or alanine, and glycine, gly. Okay, now see, that means that this one will continue. See, it's either gly or Al. Normally these 2. So these 2 is found here. Okay, it's found in here, and here, see now, gly. See now. Okay, right now, it comes this one here. So it's either this is this. So you do your combination. So let's say I got okay, I take this one here first. So you come with ala, gly, and arginine or arginine. Okay. Okay. Now, if this is the case here, that means I got meth. Okay, that means it's meth. So the next one, of course, is gly and arginine. Okay, so gly and arginine. See, 2 must put 2. So gly and arginine. Here we what? Valine. So I use this one here. 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 See, I use one here. Next one, of course, is can be valine. No valine. How about arginine and valine? Arginine. Got. Cannot. If I use one here, that means it's 8, isn't it? Tak boleh. It's 8. Because there's no other combination. So then I start with the other one. Okay? So it's meth, ala, okay, gly, okay. So ini tak boleh already. Okay. So the other one is what? Is ala, gly, not? So here. Okay, so 2 here. So it's ala, gly, and ala, alanine. Okay, so this one finish. This one finish. Then comes gly, ala, gly, ala, gly, ala, gly, gly, ala, 3. Okay, so 3. So gly, ala, gly. You see this? Okay. Okay, finish. Finish. Come on. Met, ala, gly. Okay, finish. Then, remember this is the last, okay? So ala, gly, arginine. Okay, so yeah. Ala, gly, arginine, ARG. Okay, that's here. No, that's here. Gly, ala, valine. Then last one, just nicely fit. arginine, and lysine. So this is your protein. Do you understand? Okay, it's quite fun, isn't it? Okay, so now this is how they ask you on proteins. Okay, they break it up and ask you to form back again. Now, the other question, of course, I'm going to ask you to do it by yourself. Okay, right? It's in page. Let me see. Puzzle 233. So all this require work and not being easier. You fellas never like my video, never put like, and never subscribe as well. Subscribe lah, you fools. Having to earn some money lah. I do all this extra work for nothing. Okay, now this one. Try some by yourself. Nice one here. You see now. Okay, the sequence of amino acids in a polypeptide may be determined by partial hydrolysis, partial, not complete. Into chains of smaller pieces, often tripeptide. They tell you already. Following such a partial hydrolysis, the following tripeptides are obtained from given point, blah, blah, blah. Same thing, same idea, same. Okay, blah, 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 blah. Given the N terminal, it means the starting point, is it? Of course, normally it's not true one. I mean, it's method, but never mind, they say starting point is lysine. Right? So which one is starting? So it's this much, number one. Okay? Suggest the amino acid sequence for the shortest. Okay? Polypeptide that must for 3 given. It means that all must be used once only. Okay, use once only. Use once. Okay now. Okay? Right, now try by yourself. Time is up for me. And of course now this one here tries also. Okay? The structure formula for amino acids and so forth here. Alright? Very good. Okay? Okay. So we have finished all these things already. If you look at the syllabus, all right, I finished all of them. You don't say I didn't finish, I tell you. Whack your head. Okay, look at this. Of course, all this no need already. Last time we used to go into detail all these reactions. Right? You want, you can go through yourself. Right? Okay, see here. I see. Faster. I will go through some of those things next day. All right, just to summarize all these things here, and then I would end up with what? No, I would end up. I would have to do the NMR because most of your organic chemistry, right, comes with using infrared, mass spectrometer, and nuclear magnetic resonance, which is these two I will cover probably the last one. I will probably have 2 more sessions with you. Then I'm finished. Okay. Right? You should be happy. I'm happy. Right? Now here, see how I have done, you look at it carefully here. I have done, yeah, I have done part D. Okay? Distinguish between primary, secondary, and tertiary. They ask you for alpha helix and beta sheet or beta pleated or whatever. Okay, see hydrogen bonding to carbonyl and your NH. Yeah. Tertiary between the R groups. Okay. I've done all this and we did in detail last game. Right? So now this part here, I told you here, I want you to read it by yourself. It's a book, so I cannot use it here. I will discuss with you this one here. Okay? Right? The next time I see you, I will just finish up this one here. DNA, it's very simple. They didn't ask you for, they didn't say you need to know replication. That's what we used to learn this one here. Okay? So it's a very simple hydrogen bonding with a pairing of bases in DNA. Just you need to know the structure. Right? And of course down here, degradable, I will just run through a couple of these degradable stuff. So we've done this already. Okay? Right? Degradable stuff and here and there. Okay, recognize this one here. We've done this already, okay? Describe the hydrolysis of protein A. Okay, we just done up on top here. Okay, so we have finished. Okay, one more lesson we have done quite detailed, I tell you. Okay, we have finished all these things here already. So the next time I see you, I will finish off DNA stuff here and there, and any questions you got to ask me online first, and I can explain it. I will explain about the. Some of you asked me about the what is this? The resonance structure. I'll explain it with a question. Okay. All right. So I will see you See you lah. I want to stop this. Always don't know how to stop this. Okay, here we are. Stop recording. Okay, goodbye. See you next time.